Hi everyone, welcome to this workshop. Today we practice on solving system of linear equation by elimination, or it's also called addition. So the general idea of solving system of linear equation is adding two equations and we try to eliminate one variable. For example, if you look at example 1, you will see that we have x plus y equal to 8 and x minus y equal to -2. In the first equation, you have that y is positive 1, and at the second equation is y is -1, which tell me that when we add two equations, y will be cancelled out. Let's see what happened when we add them. So we have 1x plus 1x will give me 2x, and y positive 1y minus 1y will be cancelled out. Then 8 minus 2 will give me 6. So we have 2x equal to 6. I can go ahead and solve for x by divide by 2 on both sides. So we have x equals to 3. X equals to 3 is one of my solutions. Now we have to do is back substitute into either the first equation or second equation, either one, to get the y value. Let's see if I substitute x equals to 3 into, I can choose either first or second. I would choose the first equation. So x plus y equals to 8, and my x right now will be replaced by 3 plus y equals to 8. We're gonna isolate y by subtract 3 on both sides. So we have y equal to 5 is my y value. Okay, so my final answer is x is 3 and y is 5. We can also check the answer by plug them both into the original equation. For both equations, they have to give me the true statement. So let's say check the answer. First equation, we have x plus y equals to 8, and my x is 3. X is 3 and y is 5. Equals to 8. Are they equal to each other? So we have 3 plus 5 give me 8, 8 equals to 8. That's correct in the first equation, but we're not quite done yet. You also have to plug in the second equation. So x minus y equals to -2. Again, x is 3 and y is 5. So 3 minus 5 is that equal to 2. 3 minus 5 give me -2 equal to -2, so that's correct. So my answer for the system in the equation is 3 and 5. So based on example 1, there's two things we just learned from this concept is to be able to cancel out or eliminate a variable, we need to have the same coefficient in front of it. So in this case, we need to have we have 1 in front of y, so they have the same coefficient, and we also need the opposite side of the coefficient, so that when you add them, they will be cancelled out. That's the first thing we have to learn. The second thing is the concept to solving this. We work with equation 1 and 2 to create the third one. The third maybe will be your x equal to a number or y equal to a number is a solution for x or y. Then we do the back substitutes into 1 or 2 to get the second unknown. So since I put x equal to a, so this one will give me y equal to b. We not always get x first. It depends which variable you want to cancel out. So when we do more example, you will see more clear how this concept will be applied. So we have some idea about solving a system of linear equations by elimination based on example 1. Now let's look at example 2. We have 3y equal to 14 plus x and 2x plus 22 equal to 5y. There's one more thing we need to know about solving system linear equation. There's a requirement that the system have to be in the general form, which means x and y have to stay on one side of the equal sign. So right now, first and second equation have x and y all over the place. We're gonna do is pick out each of them and write them in the general form. So in the first equation, we have 3y equal to 14 plus x. So I want x and y stay on one side. So I'm going to move x over by subtract x on both sides. We have negative x. Without any sign, this is positive 3y equal to 14. But we also don't line the negative in front of x or start an equation with the negative. So I multiply the whole equation by negative 1, which basically we change the sign of every single terms. So we have x minus 3y equal to negative 14. Okay, since the first equation already in the general form, so I will write it back here, back to the top. So x minus 3y equals to negative 14. Now we do the same for the second equation. Pick out the second equation. 2x plus 22 equals to 5y. And we want x and y stay on one side, so I'm going to move this y over by subtract 5y on both sides. Subtract 5y on both sides. We will have 2x minus 5y plus 22 equal to 5y, and 5y was cancelled out, so give me equal to 0. Then as we say that we want x and y stay on one side and constant have to stay on the other side, so I'm going to subtract 22 on both sides, which will give me 2x minus 5y equal to negative 22. Now the second equation in the general form, so I'm going to bring it back to the top. So we have 2x minus 5y equal to negative 22. So now we solve the system by eliminating one of the variables. You can either eliminate x or you can either eliminate y. So I'm going to choose to eliminate x because x has the coefficient is 1 and 2 is the small coefficient. We can easily to cancel them out by multiply the first equation first of all by 2 to make them has the same coefficient, and also we also need the opposite side, so I'm going to multiply by negative 2. We're going to distribute negative 2 into the first equation, which will give me negative 2x plus 6y equal to positive 28, and we have 2x minus 5y equal to negative 22. Now we can see that in the first equation you have negative 2x and the second equation is positive 2x. They will be cancelled out when we add two equations together. This gone, which leaves me y equal to 28 minus 22 give me 6. So y equal to 6 is one of my solution. Right now, let's review what we learned last time. First and second equation, which give me the third one. Where is your solution will be? Right now, in this case, is y equal to 6. Now we do back substitutes into either 1 or 2, the first or second equation. So I will choose to substitute into the first equation. You can pick either one, this or this one, to solve for x. Substitute y equal to 6 into, let's say I will choose the second equation. We can plug in any first or second. So I choose the second equation. So we have 2x plus 22 equal to 5y. So which will give me 2x plus 22 equal to 5. Y will be replaced by 6. Then we have 2x plus 22 equal to 5 times 6 is 30. And isolate the x, so move 22 over, subtract 22 on both sides. So 2x equal to 30 minus 22 give me 8, and divide by 2 on both sides give me x equal to 4. So x equal to 4 is my second unknown. But make sure you have to write your answer in x and y order, which means 4, 6 is my final answer. We can check the solution by plugging into both equations. They have to give you the true statement. Okay, so you see two examples. Now it's your turn to do the cell check. Go ahead, do cell check A and B. If you get stuck, go back to the example. Make sure you understand the concept. Then we will go over it in the next few seconds. So you have about 5 or 10 seconds to pause this video and try it by yourself. Then you can see the solution to check your answer. Alright, 5 or 10 seconds start now. So I believe you already have your answer. So here the answer for A and B. For problem A, the answer is 9 and 2. Make sure you write your answer in X and Y order. And answer for problem B is 3 and -2. Now let's go over each of them. So in problem A, as we see the system already in the standard form, so that's perfect. And you see y has the opposite leading coefficient, which is -1 and +1, which tell me that when I add two equations together, y will be cancelled out. And don't forget, 1x plus 1x give me 2x equal to 18. Divide both sides by 2 will give me x equal to 9. So x equal to 9 is my first unknown. My next step is back substitute into either first or second equation. So substitute x equal to 9, let's say into my second equation. Since we solving for y right now, and in the second equation y is positive, right here would save me one step. I don't have to divide by a -1 later on. So I just choose positive y, it's easier. We plug in x by 9 plus y equal to 11. Then we isolate the y by subtract 9 on both sides. So which give me y equal to 2. That's my second unknown. So final answer is x and y order. So x is 9, y is 2, 9, 2 is my answer. It's matched with what I gave you before. Now on problem B, we can choose either eliminate x or y. Look like y give me the small number, I'm gonna choose y to eliminate y. So we see that y is 2 and 6 is the coefficient. So the large common multiple of them is, or I did write wrong. The large common multiple of 2 and 6 is 6. So I need to do is multiply the first equation by 3 to get 6. And we also need the opposite coefficient. I can also multiply by -3 instead of just 3. So multiply the first equation by -3, which will give me -15x minus 6y equal to -33, and 7x plus 6y equal to 9. So when I multiply the first equation by -3, I have -6 on y and +6 on y. They will be cancelled out when we add them together. So this will be cancelled out. Give me -15 plus 7 give me -8x equal to -33 plus 9 give me -24. So isolate the x by divide -8 on both sides. So negative cancel out on here and here, and a on this side also cancel out. Give me x by itself. X equal to 24 divided by 8, give me 3. And again, that's my first unknown. Now we do back substitute. Substitute x equals to 3 into, let's say, first equation. So first equation we have 5x plus 2y equal to 11, and my x be replaced by 3 plus 2y equal to 11. So 15 plus 2y equal to 11. Isolate the y by move 15 over. Look like I don't have enough space. So 2y equal to -4. Let me bring it here. 2y equal to -4. So keep going, solve for y by divide by 2 on both sides. So it's give me y equal to -2, and that is my second unknown. And you know what I'm gonna do next? We have to write the answer in x and y order. So 3 and -2 is my solution and is matched with what I give you. In example 3, we have x minus 2/3 y equal to 1/3 and -3/2 x plus y equal to -6. So we're gonna solve the system of linear equation by elimination. So first of all, we see that we have fraction, and I believe most of us we don't like fraction. So I'm gonna show you the tip how to get rid of this fraction. We see that we have 2/3 and 1/3. So denominator is 3, so which means that my LCD would be 3. We're gonna do is multiply the whole first equation by 3. So every single term will be multiplied by 3. The goal is when this 3 times with 2/3, we can reduce or cancel out the 3. So what give me the new system equation is 3x minus 2y equal to 8. And at the bottom we have just only one fraction is 3/2, and 2 is the denominator. So my LCD on the second equation would be 2. So multiply 2 for every terms so that we cancel out the bottom of this 2, which give me the new equation is -3x plus 2y equal to -12. So now both of them already in standard form and without fraction. So my next step is eliminate either x or y. But as you see, on the x term we have +3, -3. On the y is -2, +2. So which tell me that when we add them together, they both will be cancelled out. Give me 0 equal to 8 minus 12 give me -4, and that one is the false statement because 0 not equal to -4, so it's false. Then my answer for this equation is the system equation is no solution because it's the false statement. Okay, so in graphing, basically the no solution happen when you have two lines, they are parallel to each other. Let's see. They parallel, which means they never cross over. There's no solution. On example number 4, we have 2x minus 5y over 2 equal to 19 over 2. And the second equation is negative 0.2x plus 0.5y equal to negative 1,9. So at the first equation, we have fraction, and we just learned how to deal with fraction. So the LCD of this fraction is, if you say 2, that's the correct answer. So we multiply both sides by 2. But I'm not going to distribute the 2 into the numerator. My goal is cancel out with the bottom. So which give me the new equation is 2x minus 5y equal to 19. At the second equation, we have 0.2 is one place after the decimal point, 0.5 also one place after decimal point, and also 0.9. So since there's just only one place after decimal point, I'm gonna do is multiply the second equation by 10. My goal is clear out the decimal point. If you have 2 places, then you multiply with 100. If you have 3 places, you multiply with 1,000 to get rid of the decimal point. So the new equation I will get after I distribute 10 is negative 2x plus 5y equal to negative 19. Now we have both equations already in the general form, so my next step is just need to add them together. So 2x minus 2x gone, negative 5x plus 5x is gone, give me 0. 19 take away 19, also 0. 0 equal to 0 is a true statement. So my answer will be infinite many solutions. Infinitely many solutions. And you will see this one on the graph. They will be 2 lines, but they overlap. They're on the top of each other. Ooh, it's hard to do this. They have to on the top of each other. Okay. The other way to say the solution, the other way to also answer for the solution is dependent. So you can answer either one. Okay, so the following is extra practice for you, so you can practice and master the solving system linear equation by elimination. Make sure when you solve 6 of this, you have to solve by elimination only. Okay, so you have 5 seconds to pause the video, try it, solve it. If you get stuck, go back to example, all 4 example, and also the cell check. Alright, good luck. You have 5 seconds to pause this one. If you don't pause, the answer will come up after 5 seconds. There we go. So I believe we all have the answer. Here's the solution. So hope that you have fun, and thank you for watching.